All right, my chickadees. Today we are doing something very new. You must have a ruler for this lesson. Now, as you can see, my version of the scale drawing that you have in your book is a lot larger, so I will not be using a ruler. I will be using a yardstick. Okay, but for you, you must have a ruler. Cannot perform do this homework without it. So please, go get a ruler right now. Thank you. Okay, I know this kind of looks a little wibbly wobbly wopper-sided, but it's gonna have to do. Okay, so I had to really use my brain to draw this thing up here. But I'm here with you to work on answering the questions in section 1. Today is a scale drawing. Now, a scale drawing is used to show very long distances on a small piece of paper. So, a map is a scale drawing. Okay, any map that we have ever looked at in class, especially the globe, okay? Here. This is a map of the world. Is it as big as the world? No, it's not as big as the world. This map has been drawn to scale, okay? So they have taken all the measurements and divided it down and done everything in equal proportions, okay? So when you use your ruler today, your map says that 1 inch on your ruler actually equals 1 mile. All right, and so here, is there a scale? Yes, so the scale on this globe says 1 inch equals 41, no, what? I didn't read that right. It says, the equatorial scale is 1 to 41,849,000. So they have really reduced this. I think these are in centimeters. Yeah, centimeters. I don't really know what that means. I'm really messing up right now. Don't pay attention to me. Okay. Anyways, any map we've ever looked at, it's drawn to a scale, which means taking a great distance and shrinking it down to a very small distance, usually centimeters, or inches. Okay? In your book today, you are working with inches. The scale means that 1 inch on your ruler actually equals 1 mile on land or sea. Okay, so here are the relative distances between the church, Bob's house, Ted's house, post office, store, and ball field. Okay, when you look at this scale map, and if they were to ask, you're going to measure along the red line, okay? We don't go from church to store like this. That's not the path. From church to store is along the path that they've drawn. Okay, so that's how you're going to find your answer. So follow the path. Don't look to the right, to the left, but keep straight ahead, okay? And acknowledge him in all your ways, and he will make your path straight. Remember that? Acknowledge him in all your ways, and he will make your path straight. I think that was Lucy's proverb birthday. Oh, chic, 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 chic. Okay, so March 6th, right? Proverbs 3:6. Okay, tangent, back to math. Number 1A says, find the distance between the post office and the store use your ruler to measure, so you better have your ruler by now. Always measure along the lines. So we're going from the post office to the store. Now I've done my scale map where 1 foot is 1 mile, okay? Because if I was to do it by inches on here, my whole map would be like this big and you couldn't see it. So my map is 1 foot equals 1 mile. We will write all of our answers according to scale, not in inches and not in feet, but in miles. Can you imagine if the post office and the store were 1 inch apart? Like the entire store and the entire post office. Can you imagine if your house and the post office were one inch apart and everything was this big? No. So you have to answer to scale of actual size on the earth, okay, not on your ruler. So when we measure, our answers are in miles, and they will either be a whole number or a mixed number. Okay, so here we go. They want to know post office to the store. I shall measure and you shall measure. So put your ruler on the black dot of the post office and find the store. This is 1 foot, so that means it is 1 mile. 1 mile. If you write 1, the question will be 1 what? 1 porcupine bottom? 1 Band-Aid? 1 booger? 1 what? 1 mile. Always couple your adjective with a noun. Okay. B. Church to Ted's house. Always follow along the line. So, start here. Ted's house to Bob's house is 1 foot. And then, so I'm going to put in parentheses 1 plus. And then from Bob's house to church, 1 3/4. Which means 2 3/4 miles. You've got more than 1 now, so you got to put the S on the noun. 2 3/4 miles from Ted's house to church. It's kind of like Miss Caitlin. I live about 2 miles away from the church. Okay. From the C. Ted's house to the store. Always follow along the line. Okay, so Ted's house to the store. Here we go. Ted's house to post office. Ooh, Ted's house to post office is 1 1/2. So in parentheses, 1 1/2 plus another 1. Okay, so 1 1/2 plus 1 equals 2 1/2 miles. Cool. Cool, cool, cool. Okay. D. Bob's house to Ted's house. All right, Bob's house to Ted's house, following along the line. That is 1 mile. That's really nice. I bet Bob and Ted hang out all the time and they just walk to each other's houses. Okay, then church to post office. Okay, now remember, we're always supposed to follow along the line. So do we measure like this? That's going offline. We want to stay online, so we're going from church to the post office. So, 1 3/4. If you notice, I'm using parentheses when I have to add a bunch of them. So I have 1 3/4 from Bob's house to church. We know that Bob's house to Ted's house is 1 mile. And now Ted's house to post office is 1 1/2. All right, 1 plus 1 plus 1 is 3. And 3/4 here. 3/2. 1 2 3 4. 4 1/4. 4 1/4 miles. Woo! 4 1/4 miles. So now I did that in my head, but if I really wanted to, I could do it over here on paper. 1 3/4 plus 1 plus 1.5. 2 goes into 4 2 times, so I make it 2/4, 3/4. So 3/4 plus 2/4 equals 5/4. And these three go like this. 5/4 actually equals 1 1/4. So I add this to that and get 4 1/4. Did you see how I did that? Word problems. Okay. Lastly, Ted's house to the ball field. So, Ted's house to the post office, 1.5. Post office to store, 1. 1.5 plus 1 is 2.5. And store to the ball field, 1.5. 2.5 plus 1.5 is 4. 4 miles from Ted's house to the ball field. He's definitely going to have to ride his bike or drive a car or get driven, depending on how old he is. Or take the bus or Uber or Bird or whatever. Welcome to the 21st century. We have a million ways to get there. Or walk. You could totally walk, but it'll take him about an hour and a half. 20 minutes per mile, 1, 2, 3, an hour and 20 minutes, hour 10. I mean, if he's really booking it, it might take him, yeah, I would give him an hour and a half if he's just tra-la-laing. Okay, so that's section 1. That is how you do a scale drawing. So you measure with your ruler, but you answer an actual physical difference, okay? So the scale on this one in your book was 1 inch equals 1 mile. So therefore, all of our answers were in miles, okay? Miles. Great job, everybody. I now have 1, 2, 3 more equations to go over with you. These are from section 2. I will not be doing B, C, and F. All right, this is A, D, and E. So you have to do Buttercup on your own. And then we have a couple story problems. I'm going to do 3B with you. Okay, so here we go. Charge. All right. So we need to add these 3 numbers together. 2 of them have fractions, so we work with our fractions first. 11 and 22 are our denominators. Those are very related. We can turn 11 into 22 by multiplying by 2. I multiply the top and the bottom both by 2. 3 times 2 equals 6, and 11 times 2 equals 22. Then I rewrite my other fraction. I do my fractions first, then my whole numbers. I'm adding. Actually, I'm going to move this down a bit because you can't see very well. There you go. I'm adding. Always triple check your mathematical process, okay? 6 plus 4 is 10. And boop, boop, boop. All over 22. And then I move on to my whole numbers. 7 plus 3 is 10, plus 6 is 16. 1 plus 9 is 10, 10 plus 2 is 12, 12 plus 4 is 16 again. All right, I have 10 over 22. Our divisibility rules tell us that all even numbers are divisible by 2. I'm going to go ahead and divide by the number 2. Top and bottom to reduce this proper fraction. 10 divided by 2 is 5. 22 divided by 2 is 11. So my final answer is 166 and 5/11. We need to see all of this work in your book. We need to see all of this work in your book. Okay? If you have your divisibility rules memorized and you have your times tables memorized, that's how fast your homework can go, okay? Let's do 1D together. Our fractions have the denominators of 3, 6, and 9. I know that 3 and 9 are related. 3 can become 9, but 6 cannot become 9. So I'm going to do multiples of my largest denominator. I know that 9, 18, 27. Okay, that's good. 6 can't go into 9, but 6 can definitely go into 18. And 3 can also go into 18. So I'm shooting for the denominator 18 for all of my fractions. Okay? So here I go. I begin all of that. I turn 3 into 18 by multiplying times 6. Very good. So top and bottom, I multiply times 6. That becomes 6/18. And now I turn 6 into 18. 6 times what equals 18? I hope you said 3. So I multiply the top and bottom of this fraction by the number 3. 5 times 3 equals 15. And 6 times 3 equals 18. Same denominators, looking good. Now I turn 9 into 18 by multiplying by a 2. I'd multiply top and bottom by 2. 4 times 2 is 8. 9 times 2 is 18. 18, 18, 18. They're all the same denominator. We are ready to go. Fractions first, then whole numbers. I triple check my mathematical process. I am adding. One big clue that you're going to be adding all of these numbers is that there's more than 2. When you have more than 2 numbers stacked up, the only thing that you can do is add. Okay, if you have only 2 lined up, you're probably going to subtract or multiply. Okay, but we're not we can multiply these elite geniuses, but today we're going to subtract them. Oh my gosh, sorry. Here we go. I am adding all of this together. So here I go. 6 plus 15 is 21, and 21 plus 8 is 29. Over my denominator 18, ooh, my numerator is larger than my denominator. That's improper. I need to divide down. Now I work on these. Okay? 8 plus 3 is 11, and 11 plus 5 is 14. Ooh, yeah. 1 plus 7 is 8. 8 plus 0 is 8, and 8 plus 3 is 11. 1 plus 6 is 7, 7 plus 4 is 11, and 11 plus 9 is 20. Okay, so now I have this improper fraction. When your numerator is larger than your denominator, you need to divide down, okay? 29 divided by 18. That looks like 1. 1 times 18 is 18. 9 minus 8 is 1, and 2 minus 1 is 1. Is 11 less than 18? Yes, it is. Nothing to bring down, so this is now a mixed number. Your remainder is your numerator. Your divisor is your denominator. This becomes 29 over 18 becomes 1 and 11/18. I add this to the number I already have. 1. Can you see that? Barely. Okay. 2014 plus 1 and 11/18. Well, that becomes, can you see this over here? Yeah, okay. 2015 and 11/18. Circle that, because boy do we have a lot of work for 2D, okay? So remember, you have your whole number, and when there's an improper fraction, you will add the whole number from your division to the whole number you already have and tag on your fraction. Okay, so the 2014 and 29/18 becomes 2015 and 11/18. Okay, moving on to 2e. I have 8 and 4 as my denominators. I need to get them to be the same. 4 and 8 are totally related. I can turn 4 into 8. I multiply times 2. 3 times 2 is 6. 4 times 2 is 8. I bring this one over. Now, I double check, triple check my mathematical process. I'm subtracting. 3 minus 6 can't be done, so I need to borrow from that top whole number. That 9 becomes an 8. Remember, it is borrow, add, math. Okay, borrow, add, math. When I borrow a whole number, I need to turn that whole number into an improper fraction. Numerator and denominator are the same. I'm working with the denominator 8, so I make it 8 over 8. I add that to the fraction I already have, 8 over 8. That becomes 11 over 8. I bring the bottom one over, triple check my mathematical process, subtract. 11 minus 6 is 5. And my new denominator is 8. And now I subtract my whole numbers. 8 minus 4 is 4. I bring this back, okay? 4 and 5/8. Do I need to reduce 5/8? No. Do I need to reduce 11/8? No. I reduced that one already. Okay, so that is how you do 2A, D, and E. Woo! Keep going, saints. You can rock this completely. Are you ready? Yes, you're ready. Okay, please do BCF when we're done with the video. And I'm going to talk about 3A and 3B. Here we go. So talking about 3A. Michelle bought 6 yards of cloth at $1.50 per foot. Yards and feet, those are not the same, so you're going to have to do some converting. How much did the cloth cost? All right, I got to do some erasing of stuff so I can do some math on the board. Here we go. Okay, so here we go. I'm going to readjust my camera here. Let's kind of blast through this, okay, because this video is getting a little long. So, she bought 6 yards, and it is $1.50 per foot. Okay, so I'm going to change my yards into feet and then multiply, okay? So 6 yards becomes how many feet? Wow, that looks really sloppy. Okay. Yards to feet, multiply. Multiply. There are 3 feet in 1 yard. 6 times 3, 18. So she bought 18 feet, and now it's $1.50 per foot. Okay, so $1.50. Please make sure you put your $ in your equation so you remember that the answer has to be about money. Okay? Times 18. 8 times 0 is 0. 8 times 5 is 40. Carry that 4. 8 times 1 is 8 plus 4 is 12. Placeholder. Bye-bye. Bye-bye. It's been a while since I've done this on the video. Here we go. 1 times 0 is 0. 1 times 5 is 5. 1 times 1 is 1. Add those two together. Can you see this? All right. $0 cents and $27. Whoa. So, Michelle spent $27 on material. My final answer is Michelle spent $27 on material. I bet it's fancy. What is your final answer? Remember, on the story problems, we get to be creative individually. Okay, as long as we answer the question, we are able to be creative. The question is, how much did the cloth cost? Michelle spent $27 on material. Wow, I did not use a lot of those words in the sentence. A better version would be the cloth cost $27, but I guess that kind of answers it. Wow, Miss Kaylin, do you need a cup of coffee? I might need a cup of coffee. That's 3A. Okay. Be really careful with that. She bought in yards, but the cost was in feet, so you had to change something. You could have changed the cost, multiplying $1.50 times 3, and then multiplying the yards times the new cost, or you can turn the yards into feet and multiply them. I think that's right. Anyways, okay. Anyways, we got the answer right. So many ways to skin a cat. Ooh, how morbid. All right. Mr. Montoya drove for 7 hours at the average speed of 59 miles per hour. How far did he travel? Okay, so the question is, how far did he travel? That is distance, okay? That's miles. Now, this is what I'm going to do. I draw a line, and I break it up into 7 hours. 1, 2, 3, 4, 5, 6, 7. Okay? And each hour he went 59 miles. 59, 59, 59, 59, 59, 59. Okay? So you can add up all the miles, or we can multiply, right? 59 miles for 7 hours. 7 times 9 is 63. Carry that 6. 7 times 5 is 35. Plus 6 is 41. So in 7 hours, Mr. Montoya drove 413 miles. That's farther than Carmel. Give that a beautiful circle or square, or whatever you'd like to do. As long as the reader knows this is the final answer. Okay? Mr. Montoya went a very far distance. The point is, these are each hours, and this is how far he drove per hour. Every single hour he drove 59 miles, and he went for 7 hours, so that's how you do that. All right. You've been equipped and empowered. I encourage you. You are ready. You can do this. Now finish your homework. Go get it, chickadees!